Hello, ladies and gentlemen in between, and welcome to the fourth episode. That was 8, sorry. Fourth episode of Maths with Hamblin with your beautiful host, Hamblin. And last episode, we covered how to do simplification with SURDs, so taking a horrible, nasty expression with SURDs and making it into a lot simpler with nicer numbers and smaller numbers. And I promised, as last time, that I was going to do some practice problems for you here, so let's do exactly that. So, I'm going to start with root 28 and we're going to simplify this bad boy. Now, as you'll recall, we've got a single square root here, so there's not much we can do to it, but we can break it up into 2 square roots and then use that to make it into some nice numbers. So, as you remember last time, the strategy here is to find a square number that goes into 28. Now, let's think about that. 4, that goes into 28, so let's use that. That is the same thing as 4 multiplied by 7. Sorry, my brain just doesn't work when I'm recording, funny enough. Right, now we can break that up into root 4 times root 7, which is the same thing as 2 times root 7. Ooh, sorry, that shouldn't be a 1. Boom, there we go, we've simplified our first expression. Now that was pretty easy, probably only worth 1 mark, but still, progress, am I right? Now, root 9 over 16. I'm sure you can see this is pretty obvious. We can just break this into root 9 divided by root 16. Now this one is extra special lovely because root 9 and root 16, those are really easy numbers, we all know, right? Root 9 is just 3 and then root 16 is 4. Oh my god, look at this business. We take the square root of a rational number and we get the rational number back. And the whole point of the question, we've simplified these down into nicer numbers we can deal with. Now that's brilliant. On to the next example. Okay, my boys, this next one we're going to do is a rationalizing the denominator question. And if you remember, rationalizing the denominator means we're just going to fiddle with the expression of it until we get the denominator in a nice rational number form, not an irrational form, because that's a lot nicer to deal with. So, looking at our expression here, it doesn't look too easy to work with, but if we recall from last time, we can do a clever trick. We can multiply the top and bottom by 3 minus root 7, because then we can use that identity and crush those square roots down to something a lot nicer. So if I multiply the top and bottom by 3 minus root 7, notice on the bottom we've got a plus b times a minus b. We can use our identity, a squared minus b squared. So this is going to evaluate to 2 times 3 minus root 7 over, now we're going to get 3 squared minus root 7 squared. 3 squared is 9, root 7 squared is 7. So we're going to get 9 minus 7, or in other words, 2. And now look at this. This is really good, right? We've got 2 times the thing and then divided by 2 again. So we're just going to get the thing back. They cancel out nice and lovely jubbly. And we're going to get 3 minus root 7. There's a rationalizing the denominator question. Done very nicely. Easy bones. Okay, my boys, let's look at this one. Now this one looks pretty terrifying, right? We've got a root 192 plus a root 12, all of that squared and then divided by that horrible thing on the bottom. But not to worry, let's take this step by step. Now, your first instinct when you look at this might be, well, all the previous ones we've done, we could rationalize the denominator first and it works pretty well. Well, if we look at this case up here, we've got this horrible thing squared. So if we try and multiply the top by root 7 minus root 5, we're going to have to expand 3 lots of brackets, and it's probably not going to be nice. So what instead, we can be clever, and we can think, well, root 12 and root 192, they look a bit suspicious. They look a bit suspicious numbers. What if we can simplify those down to just a number times the square root of something? So let's try that right now. Root 12, as we learned previously, is just 2 root 3. And root 192. Now, it might be a reasonable guess that you want to combine these terms, right? Because questions tend to be nice and simple like that. So if you get out your calculator and you do 192 divided by 3, you'll see that it's just exactly 64. So 192 is 64 times 3. So that's equal to root 64 times root 3. Don't worry, all I did was just factor that and then split up the roots. Now, root 64, my gentlemen and ladies in between, it was 8. And then look what's going to happen here. This is really nice. 2 root 3 plus 8 root 3 is going to be 10 root 3. And then when we square that, we're just going to get a nice number. And then we can rationalize the denominator. This strategy has worked really well. So let's keep going. So replacing the root 64 here with an 8 squared over root 7 plus root 5. This top thing here is going to be 10 root 3 all squared, which is going to be 10 squared times 3, or 300. 300 over root 7 plus root 5. And now let's take a look at that. That's kind of cool, right? We had this nasty, horrible, irrational term, and then we squared it. But it just wound up being a nice integer, and such a nice multiple of 100. Maths is pretty cool like that, you know, just crazy stuff, right? And now we've got a classic situation here of rationalizing the denominator, so let's go ahead and do it. Rightio. Let's use our identity, that this is going to round up to root 7 squared minus root 5 squared, or 7 minus 5, as it's more commonly known, which is 2. And I'm going to keep this top one here. All over 2. Now that equals 150, 300 divided by 2, pretty simple, times root 7 minus root 5. Okay, now let's distribute that. You get 150 root 7 minus 150 root 5. Now, there's pretty much nothing left to be done with this. 7 and 5 are kind of too small to pull out some nice things like we did with root 192 up here. And these aren't like, we can't really combine them, so we're actually done. There we go. We fully simplified that monstrosity to just this nice little expression here. No nasty denominators, just multiplication and adding of roots. And there we go. That's all the practice problems I have done for you today. To sum up, simplifying SURDs was taking a horrible nasty expression with SURDs, crushing it down using our algebraic tools, rationalizing the denominator, breaking up SURDs and expanding brackets until we get to nice, clean expression, a nicer and cleaner expression than we had before. For example, look at how nasty this is compared to how nasty this is. Still kind of nasty, but it's nowhere near as nasty. And that is pretty much the rub when it comes to rationalizing SURDs. And that's all of SURDs, pretty much. And now, next time, we can start covering the real interesting part of Chapter 2, which will be introducing what functions are and getting into polynomials now. Thank you very much for watching the 4th episode of Maths with Hamblin. I've been your host, Hamblin. Hope you got something nice out of that, and goodbye.